Welcome to a video that will prove the vector projection formula. Let's start by reviewing vector projection. If we want to project the red vector u onto the blue vector v, we use this notation here, and the result would be this gray vector here. And the formula to determine this vector projection would be u dotted with v divided by the magnitude of v squared times vector v. So in this video, we want to show where this formula comes from. So let's go ahead and set this up. Again, we'll call this vector u. We'll call the blue vector vector v. So we're projecting u onto v. And let's go ahead and call the projection vector w. So vector u and vector w would form a right triangle. And we'll call this angle between them theta. So using right triangle trigonometry, we could say cosine theta would be equal to the magnitude of w divided by the magnitude of u. Remember, our ultimate goal is to determine the formula for vector w, which is the projection of u onto v. And let's go ahead and state that. So if we wanted to solve this for the magnitude of w, we would just multiply both sides by the magnitude of u. So we'd have the magnitude of w is equal to the magnitude of u cosine theta. Let's go ahead and call this equation 1. From an earlier proof, we showed that cosine theta is equal to u dotted with v divided by the magnitude of u times the magnitude of v. And of course, this gives us another way to determine the dot product for u and v. We could say that u dotted with v is equal to the magnitude of u times the magnitude of v times cosine theta. Let's go ahead and call this equation 2. Now we're going to multiply equation 1 by the magnitude of v over the magnitude of v, which of course is just equal to 1. So we're going to take this equation here, and now it's going to be the magnitude of w is going to be equal to the magnitude of u times the magnitude of v cosine theta all over the magnitude of v. So again, here's the magnitude of v divided by the magnitude of v that we multiplied by. We'll call this equation 3. And now what we're going to do is perform a substitution with equation 2, meaning we're going to take this numerator here and replace it with u dotted with v. Let's go ahead and do that on the next screen. Let's go back and take a look at that again. We took the numerator of this fraction here and replaced it with equation 2, where the right side was equal to u dotted with v. Now that we have a formula for the magnitude of vector w, the last thing we need to do is make sure that it's parallel to vector v. Remember, we're projecting u onto v, so if it's pointing in the same direction or at least parallel to vector v, it must be the scalar multiple of v. So we're going to take the magnitude of w and multiply it by the unit vector in the direction of v. So vector w is going to be equal to its magnitude, which we found from this formula here, times vector v normalized. So we'll have vector v divided by its magnitude. And now we have the formula for the projection of u onto v, which is vector w. So we have vector w is equal to u dotted with v divided by the magnitude of v squared times vector v. So we have the projection of u onto V, which is what we were trying to prove. And there we have it. I hope you found this proof helpful. Thank you for watching.